Ladies and gentlemen, it's a pleasure to be back here at the Arianespace Center for the third launch of Ariane 5 this year, exactly 1 month after our last successful Soyuz mission for O3B. Thanks to our reliable launcher Ariane 5 ECA, this dual launch will deliver tonight Alphasat for Inmarsat and INSAT-3D for the Indian Space Research Organization, ISRO, into a geostationary transfer orbit. Our launcher will carry a total payload mass of nearly 10 tons into orbit and will have a window of 1 hour and 18 minutes to perform its mission. One additional service tonight, Ariane 5 will be able to optimize the target orbit to reach a 3.5-degree inclination as requested by the customers to increase the life of both satellites. I would like to thank Inmarsat for giving Arianespace tonight the opportunity to launch the largest telecommunications satellite ever built in Europe, and by the way, the largest satellite ever launched in upper Ariane 5 position. Alphasat represents the outstanding achievement of the first public-private partnership concluded between Inmarsat and ESA in the space industry, and will be the 8th satellite launched by Arianespace for Inmarsat. It will provide advanced voice and data mobile satellite services over Europe, the Middle East and Africa. I also thank warmly ISRO, the Indian Space Agency, for trusting Arianespace once again for the launch of its satellite INSAT-3D. INSAT-3D is the 16th satellite delivered into orbit by Arianespace. It belongs to a long series of satellites symbolizing the partnership established between Arianespace and ISRO over the last 30 years. This partnership began with the launch of Apollo on Ariane 1st in June 1981. INSAT-3D is a meteorological spacecraft dedicated to bringing weather forecast services to India and handling emergency weather issues. Our 70th Ariane 5 is now ready for launch. And now, ladies and gentlemen, off we go.
Greetings, everybody, wherever you may be, and welcome again to Kourou, the home of the Ariane family, for today's live broadcast of Arianespace flight number 214. A double launch, Alphasat for Inmarsat and INSAT-3D. UK, Europe, and India represented tonight on the customer side. Joshua Jample here on the broadcast side with Claude Berna, ex-Arianespace. Hi.
Hi, Joyce and everyone. Here in Kourou, all the parameters are green, weather is fair. Ariane 5 and the 2 passengers are waiting for liftoff, due in 11 minutes.
We're taking a look at the launch vehicle here. She stands roughly 50 meters tall in 2 parts. The lower composite, you saw the main stage and the boosters, and the upper composite.
So the upper composite is composed by the third stage, what we call the ECA, with cryogenic propellant inside, then the vehicle equipment bay, and that is the fairing, the 7 meters fairing long. And inside the fairing, we found our 2 satellites. In upper position, Alphasat, more than 6.6 tons.
That's the biggest upper berth we ever had, as Stefan Israel said.
And in the inner position, this means that is inside the Silda 5, we have INSAT-3D, 2 tons and 61 kilograms. We will present the 2 passengers later in detail.
And we'll describe each stage in turn and in detail as it's functioning, so you can follow Ariane on her mission. We're coming to you live, as always, from the Jupiter Mission Control Center, the nerve center of the space base. A look at some of the people making the mission happen. Stefan Israel, you saw, we're in Arianespace High Command with him, Louis Laurent.
And should any problem arise during today's countdown, these people will make the final decision and what to do about it. So we had a presentation now of the launcher. Take a look at Alphasat, as described Pierre-Yves Bertin, the program director.
Alphasat is designed to provide communication services to mobile users. It features a large umbrella-shaped reflector, which purpose is to focus RF beams to specific points on Earth. This makes best use of the satellite capacity at a given time and allows redirecting the beams to follow up with the user's movements. Alphasat is based on an AlphaBus platform built by ASRO and TAS with the support of ESA and CNES. It weighs 6.6 tons for a platform capability of 9 tons. Over the past years, Arianespace provided Inmarsat with analysis and test results, demonstrating the ability of Ariane 5 to achieve their mission. In the past weeks, the launch campaign has been conducted according to plan. Alphasat will join the 3 Inmarsat 4 satellites already in orbit. New onboard technology, developed with the support of the UK Space Agency, will allow Inmarsat to enhance the constellation throughput over Europe, the Middle East and Africa. It is therefore with great pride that Arianespace will be launching Alphasat tonight.
Outside, waiting. Inside, the project managers, other key players involved in the mission, this time on the customer side. We have two.
And now take a look at our second passenger, INSAT-3D, and we'll be hearing from Arianespace Luca Kekio, the second program manager.
For the launch today, INSAT-3D will be the co-passenger in the lower position beneath the cylinder. INSAT-3D is a meteorological observation satellite built by the Indian Space and Research Organization, ISRO. The satellite will be a major asset for India, providing hurricane warning system as well as search and rescue services. INSAT-3D will be the 16th satellite launched by Arianespace for ISRO in the past 32 years. The first one, Apple, was launched in 1981. This long-standing relation with ISRO has allowed us to create a fruitful and tight collaboration based on mutual respect and comprehension. Collaboration that has allowed us to tune our services in the most appropriate way to ISRO's needs. And GSAT-7, the next satellite we will launch for ISRO, has arrived in Kourou on June 12th and is currently being prepared for its launch. I would like to thank the ISRO teams in Kourou, Bangalore and Hassan, whose competence and teamwork allowed us to prepare this launch in a timely and efficient way.
Skies are pretty clear. We should have reasonably good visibility for liftoff. You're going to hear the voice of the range operations manager in a moment, also called...
Attention pour la séquence finale lanceur.
There's his voice. He's the DDO. He calls out the key milestones in the mission.
Top H0 moins 7 minutes.
And there's one at the 7-minute mark. We're in the final moments of the final countdown. Why is this stage important?
So we now passed a key milestone in the launch chronology. In the final 7 minutes prior to launch, we are in the synchronized sequence or automated sequence. In this period, the following things happen. The launcher is fully automated. Right now, the onboard computers are running their final checks. Hundreds of parameters are being validated and confirmed for flight.
On the left, the green status panels tell the status of all the systems needed for a launch. The launch base, telemetry, weather services, safety, and of course the launcher and the 2 satellites.
And all these panels must be green, of course, in final to give the final go. Every Arianespace mission has its own preparation campaign, and we have a film coming up now which will show you how the vehicle is put together.
The elements that make up Ariane 5 come to the space base in Kourou, and their assembly begins around the lower or main stage. The first operations start here in the launcher integration building. The 2 solid boosters are then transported to the launcher integration building for assembly on either side of the lower stage. Then the upper stage is integrated onto the lower stage. The vehicle equipment bay, housing the 2 computers, is then mated atop this. Ariane 5 is now complete. Only her 2 passengers are missing, and at this stage, she's moved to the final assembly building.
Preparation of the satellites is carried out in parallel with the launcher in buildings dedicated to this purpose. INSAT arrived on June 11, and Alphasat arrived 1 week later. Their preparation included weighing and testing by special teams in clean rooms. When these tests were completed, the satellites were filled with propellant. They are transferred to the final assembly building to be mated on the launcher. Arianespace and its customer teams oversees the final preparation activities called combined operations. Arianespace and customers meet every day to review ongoing activities and set plans for the coming days.
These meetings gave the green light for the 2 satellites to be placed under the fairing. The heavier Alphasat was placed in the upper berth and INSAT-3D in the lower. The day before launch, Ariane 5 is rolled out to her position on the launch pad. All is ready now for her mission. And that mission gets underway in just 4.5 minutes from now. Other key players on the satellite side, we're going to be showing you the satellite mission directors on the Alphasat side, then on the INSAT side.
And the Satellite Mission Director, or GMS, is a customer interface with Arianespace. Is the one deciding on the final chronology if the satellite is ready for launch, which is the case tonight. As you saw in the faces, these people are very concentrated since the launch represents the most delicate phase in the life of the satellite.
And those satellites together weigh 8.7 tons. In all, we're lifting almost 10 tons tonight, total 9.7 to be exact. Only possible with the heavy lift Ariane 5, the only commercial launcher on the market capable of lifting such a heavy payload. These are the DMS
on
satellite
side.
On the,
so could I say hello to our listeners in ISRO Bangalore and in the Asan Tracking Station in India? I went there many times, you know.
Some 1,500 people working around the space base in all. Our cameras here mainly in Jupiter, the control center, which is the heart of the action, but there's a lot of other people that work in a lot of other sites around the base. And we want to show some of them to you now. This is one place that's very busy tonight.
And this is the Launch Control Center, or CDL3, where the launch management teams are working under the direction of the Launch Operation Manager.
What's it like up there? What's happening now? Because you've been up there.
We have 3 main teams. The first one under the authority of Christian Lardo, what we call the Launch Operation Manager. He heads up the first group. He coordinates also the mission control for the final authorization for launch. And when all conclusions are right, he then okays the automated sequence at -7 minutes, which we saw.
And who leads up the second team?
So it's headed by the Ariane production manager, today Pierre Destin, for his first time.
So in all, we're talking about, what, 100 people roughly?
Yes, 100 people and 20, sometimes 100 people and 30. And this is a third team with Sébastien Gasparini, Launch Production Quality Manager.
And these teams are closer to the pad than we are. We're about 15 kilometers away. They're right up close, right? About 3 kilometers away. Europe's space base covers a lot of ground. It's about the size of Singapore, 750 square meters, I think. A lot of different jobs and professions.
So here in Jupiter, you see the operational teams, but in fact, to launch Ariane, we also need to have security, support from the Army, firefighters, journalists, and many other professions.
Journalists, even.
Yes, of course.
One of the last things you're going to see before liftoff, I want to take a moment to show it to you, the propellant feeder arms. Those are the yellow bars in the center of your screen. We're going to zoom in on them, and we'll have a split screen shot, and Claude will tell us all about it. This is the split screen.
So liquid hydrogen, on the left, liquid oxygen on the right. So the upper stage tanks need to be filled up to lift off as the cold liquid propellant inside evaporates under the Kourou environmental condition. These arms will be pulled back at 5.5 seconds before ignition. That's what we start at T0 minus 1 hour 20, an admission and outgassing phase, which means you top up the tank with liquid oxygen and liquid hydrogen and take out the gaseous hydrogen and oxygen to keep the pressure stable without the tanks. And that is done through the arm you see.
All right, so watch for that at -5 seconds. The DDO is going to call out the 1-minute mark very shortly. We'll explain the final ignition sequence in a moment, but before the engines are ignited,
attention pour -1 minute.
He's going to call out the 1-minute mark. People in the hall here are going outside to the 2...
Top H0 -1 minute.
We're into the final 60 seconds. I was saying the people outside, there are 2 terraces here, and you get a fine view as Ariane lifts off. All that's left to explain, Claude, the final ignition sequence. What are we going to see?
So at H0, the DDO calls out allumage Vulcain. Allumage is ignition, and Vulcain is the name of the engine. That is main stage ignition. But we do not lift off yet. In fact, there will be a 7-second wait. For 7 full seconds, the computers are checking the performance of the main engine as it is functioning and checking it on the pad. Because once it's liftoff, it is too late to fix a problem after that.
We're going to cut away. We'll let you listen to the DDO as he calls out the final countdown. Enjoy the launch, watch the engines, and we'll be back.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage Vulcain. Allumage EAP, décollage. paramètres à bord sont nominaux.
And right up through the clouds she goes at 16:54 local, and right on time. Ariane 5 beginning her mission, lifting off perfectly from the ground here in French Guiana with a lot of fire, beginning her third mission of the year. The DDO is saying that all is okay on board. These beautiful shots, always impressive for the people on the observation sites here at the base, in their cars or on the beaches, watching Ariane rising into the sky, leaving a trail of gold.
And we are about 15 kilometers from the launch pad, and even here you can still feel the sensation of launch, but if you're watching from the closest viewing station, which is only 5 kilometers away, you can really experience the sensation of the acoustic noise from those two boosters. They are providing 90% of our thrust right now, propelling the launcher along this trajectory and even higher velocity. A launch is something quite sensational to witness.
I imagine you've seen many, many of them.
Outside, very few. I am always either here in Jupiter or in Launch Center.
Working, yeah.
The one I saw was from the VIP view.
There are people watching at the Toucan observation site right now.
Yes, but my preferred place to watch is from the beach in Kourou. The scene by the sea is very impressive.
Also impressive is the 780 tons that Ariane's weight is at liftoff. She's burning 5 tons of fuel per second, 2.5 tons in each booster. And the core stage burning another 300 kilos per second. She's following the program in the onboard computer, which is giving all the orders. We're in the first of 4 flight phases. We'll describe each in turn so you can follow Ariane. Right now is the first flight phase, the core engine burning in the main engine and the 2 boosters. The boosters are going to extinguish. Right now you can see them happening. Those are the 2 points of orange light on either side, and the white light in the middle is the core stage continuing to burn.
And they will fall at 500 kilometers from shore in a protected area.
Everything normal on board. You remember the last time we had a daytime launch?
I suppose it was for the first launch of Vega. It was in February 2000.
February of last year, I think.
Last year at 7 a.m. in the morning.
Early morning launch, right.
Morning,
All right, all is functioning perfectly on board. We're into the second flight phase. The single core stage engine's burning right now, and burn for about 9 minutes in all. We're coming up on separation of the fairing in about 10 seconds. You'll hear the DDO call out that milestone. We can separate the fairing now because we're out of the Earth's atmosphere. We no longer need it.
And shaped like an OGA, the fairing protects the 2 satellites during the atmospheric flight. Fairing is 17 meters long and has an external diameter of 5.4 meters. And separation is just given by 2 systems, one horizontal, one vertical, giving the 2 halves the necessary pitch for the lateral maneuvers. As
you saw the separation of the fairing, revealing Alphasat, our first passenger. That's the black and gold box. You'll be hearing a lot about Alphasat in the films coming up. It's a big achievement for Europe.
And this program demonstrates the finest technology Europe has to offer through implementation in a public-private partnership,
PPP.
or PPP, between Inmarsat and ESA.
It's the largest telecom satellite ever built in Europe at over 6.5 tons, carrying also 4 ESA, European Space Agency technology demonstration payloads for Portugal, Italy, and Germany. And it's the 8th satellite launched by Arianespace for Inmarsat, the British group, and we're going to be going to a film on Inmarsat, and you'll be hearing from their CEO, Rupert Pearce.
This is an exciting day for Inmarsat as we prepare to launch Alphasat. It's very much a joint endeavour, and as a public-private partnership venture, represents an important milestone for the European space industry. I believe that the Alphasat program demonstrates powerfully all that Europe can achieve in the highly competitive field of global aerospace services and solutions, with the support of our core partners, in particular the European Space Agency, Astrium, the UK Space Agency, the European Investment Bank, and 3 UK development agencies. We have together financed, architected and constructed the largest, most advanced and complex commercial satellite ever built in Europe. Arguably the most advanced mobile communication satellite built anywhere. As the leading provider of global mobile satellite services, Inmarsat owns and operates a fleet of 9 satellites in geostationary orbit. Every day, these spacecraft, flying over 22,000 miles above the equator, provide vital data and voice services to governments and commercial enterprises across 6 continents. Our global mobile connectivity services are helping to make this a safer world on land, sea, and in the air. When a ship is in need of help, it is Inmarsat they turn to, as the world's only provider of the life-saving global maritime distress and safety service. If there is disaster on land, Inmarsat services arrive with the first responders and have been proven time and again as highly resilient and dependable services in times of crisis. The award-winning Inmarsat-4 fleet, which will soon include Alphasat, ensures that broadcasters can deliver live news, however remote the location. This same fleet is opening up opportunities for economic growth in developing regions, enabling the rapid deployment of secure, reliable mobile broadband communications in areas where terrestrial networks are not available, from the Amazon to the deserts of southern Africa. Governments across the world are also Inmarsat customers, whether helping peacekeeping forces in remote regions or providing border security. Our services continue to be in great demand. The geographic spread of Inmarsat customers is a testament to the unparalleled reputation we have developed over 30 years for outstanding innovation, reliability, and service quality. Alphasat is a further step forward in our strategy of enabling an increasingly connected world. The purpose of Alphasat for us is a simple one: to enhance the capacity and increase still further the redundancy we can offer through our global L-band Inmarsat-4 network. This latest spacecraft will serve the busy communications markets of Europe, the Middle East, and Africa. But our plans go beyond adding capacity alone. We're developing new services to utilize the unprecedented processing power available on Alphasat thanks to new payload capabilities developed and constructed by our manufacturing partner, Astrium. Much of this extraordinary innovation was produced in the UK. This is the culmination of many years of careful planning by our team of world-leading engineers. Once the Ariane 5 rocket has delivered Alphasat into orbit, Inmarsat's team will begin flying the spacecraft, testing its systems and, over the coming weeks, ensuring that it is ready to begin delivering vital communications services. As I said, this is a truly exciting day for us, and in addition to our partners, I'd like to pay tribute to the many Inmarsat staff who have helped make this launch a reality.
1 minute to go in the lower stage burn. Tell us about the lower stage.
This is the main cryogenic stage. It's 5.4 meter diameter, 31 meters long. It is powered by one Vulcan 2 engine that burns liquid hydrogen and liquid oxygen. And the Vulcan 2 engine provides up to 1,004,000 Newton of thrust in the vacuum of space. Its nozzle is gimbaled for pitch and yaw control.
Where there are different propulsion systems on Ariane 5, of course. There's cryogenics and the solid fuel.
Exactly, and of course cryogenic is more efficient than solid propellant, which is used in the booster. Basically, solids are for getting up off the ground and away from the pool of the Earth, while cryogenic are more sophisticated. They are used for more precision orientation of vehicle.
You heard the DDO call out extinction of the lower stage and separation of the lower stage and ignition of the upper stage, all that coming right on time. These are 3 commands given by the onboard computer in about 13 seconds. So we're into the upper stage burn. That's the 3rd powered flight phase, 1 single engine. On this interesting mission tonight, Arianespace providing populations across the world with new services for protection and prevention. Alphasat carrying many new items on board, a film on the Inmarsat ESA project now. I think we may have lost part of the sound on the English track during the film. Not sure, but if we did, we do apologize for that. Take a look at the upper left of your screen. The cursor on the line shows Ariane's trajectory and how the flight's progressing.
And the white dot on the curve is the actual position of the launcher. Below are two lines, some letter A and V, means velocity. Go back later.
Our next film featuring a word from Jean-Yves Le Gall, president of the CNES. Back with more in a minute.
An important milestone for this project, achieved through multilateral cooperation. First of all, the Alphasat satellite itself is the first to use the Alphabus platform, which meant that the European Space Agency and Inmarsat had to work together to develop the satellite, incorporate it into a business model, and now launch it. There was cooperation at three levels. First, between the space agencies and the manufacturers. As you know, CNES created the Alphabus platform used by Alphasat and then developed it with the European Space Agency. Secondly, CNES and the European Space Agency then worked closely with the prime contractors, Astrium and Thales Alenia Space, to develop Alphabus. Thirdly, these two prime contractors built the Alphabus platform together. Alphasat is the first satellite to use the platform, but there are sure to be others, because Alphabus is currently the best telecommunications platform in the world. Its modular design means it can be adapted for bigger telecommunication loads. It uses all the latest cutting-edge technologies, and I'm convinced it will be a great success.
I was just saying that...
yeah, I cut you off. The two lines on the lower left, A and V.
So A and V. So A means altitude, and we are flying at 154.3 kilometers. And V means velocity, and the speed is 7.80 kilometers per second.
While you were watching the last film, we were picked up by our next downrange tracking station on Ascension Island, this UK station in the Atlantic Ocean. All of Ariane's trajectory has been designed to be followed from the ground, whether by land or by sea. The launcher is sending back radar and telemetry to keep constant watch on her vital systems. Back with more. Over to Astrium now, builders of Alphasat.
Alphasat is remarkable. It's a truly European program, and it is about working together. there's another spectacular dimension in Alphasat. This satellite brings 3 outstanding achievements in one program. First, innovation. Alphasat is the newest payload technology, for instance, featuring the most advanced digital processors from Astrium to deliver unprecedented flexibility for the allocation of frequency, spectrum, spot beams, and power. Size. Alphasat is the A380 in telecommunications satellites, with no equivalent today in the world. Third, preparation of the future. Alphasat flies 4 hosted payloads, so-called technology demonstrators, furnished by ESA, and Astrium is involved in 3 out of those 4. I would like to thank Inmarsat, ESA, and the space agencies for having entrusted us, Astrium, and making this possible.
And I will add that Alphasat is also carrying something called stationary plasma thrusters, a propulsion system developed by SNECMA in its Vernon plant in Normandy. It was used for the first time on Smart 1, the lunar probe, launched by Ariane in 2003, along with INSAT-3D. Now take a look over Thales Arianespace, now builders of the Alphasat platform, Alphabus platform, let's say.
We're going to be hearing from Natalie Smirnov in the film. Coming up.
It is a great honor for Thales Arianespace to be part of this very large program, Alphasat, the largest European satellite ever built. Alphabus is the most powerful platform today, and we have contributed to 50% of it. The service module being integrated and tested in our facilities in Cannes. Our team in France, Belgium, and Italy have deployed all their expertise when designing and producing the overall mechanical structure, the avionics, and the electrical propulsion system. Being in charge of the avionics, that includes the attitude orbit control, the data handling, and the onboard processing, we have developed the flight software, and we will support the early operation just after the separation. Thales Arianespace also contributed to the payload of Alphasat, in particular with the very innovative QV band experimental mission. I would like to thank everyone involved in the project. Inmarsat for their strong support all along the project, ESA and CNES for their wide support to the European industry, Astrium, our Alphabus industrial partner, our suppliers, and indeed all my colleagues at Thales Arianespace who have worked so hard in structuring this very challenging program. I believe this is the beginning of a very important journey. Congratulations to everyone.
Just another word on the platform. This mission will be testing its avionics performance and operations.
So Alphasat will follow Alphasat later on, but now over to ISRO. Our next film will look in INSAT in the Indian Space Research Organization.
The weather is a harbinger of life to a country like India, where 70% of the population, either directly or indirectly, depends on agriculture. Natural hazards like cyclones, floods, drought, cloud bursts, landslides, etc. directly affect life. For the first time, INSAT-3D will provide accurate observation of sea surface temperature. Other new products from the imager include fog, forest fire, smoke, snow cover, transport and movement of atmospheric pollutants, and various agro-meteorological parameters such as radiation, land surface temperature, etc. The INSAT-3D imager will also ensure continued observations of parameters such as atmospheric wind, precipitation, outgoing long-wave radiation, and upper tropospheric humidity. It is a matter of national pride that the entire data processing for INSAT-3D imager and sounder has been developed at SAC Ahmedabad under IMDPS. The geophysical data products of INSAT-3D will be disseminated through IMD New Delhi and MOSDAC of SAC Ahmedabad for operational utilization as well as for research and development. INSAT-3D is an outstanding example of India's technological and scientific strengths in harnessing space technology for the development of the country. The launch of INSAT-3D is a major milestone for India's space program, which will greatly enhance our capability to observe, understand, and predict the weather.
INSAT-3D, the 16th satellite launched by Ariane for ISRO. Another look at ISRO now with its chairman, Dr. Radhakrishnan.
INSAT-3D is an advanced weather satellite of India to be placed in the geostationary orbit at a longitude of 82 degrees east. It will add a new dimension to the meteorological observational capability of India. Currently, we have 2 satellites providing imaging capability from geostationary orbit, the Kalpana and INSAT-3A. In INSAT-3D, we have made significant improvements in the imaging system. In the sense, we have added imaging in the middle infrared region, enabling us to take pictures of clouds in the night. We have also made improvements in the thermal infrared imaging system so that we could estimate sea surface temperature more accurately that are required for the weather prediction system. But the most important part of INSAT-3D is the atmospheric sounding system. This sounder provides us profiles of temperature, humidity, and critical trace gases at 22 levels between the altitude of 1 kilometer to 20 kilometers. And such vertical profiles would be available for a selected region over Indian landmass every hour. And for the entire Indian Ocean region, such profiles would be available once in 6 hours. This is going to be really a boon for the country for weather prediction and disaster warning. Also, INSAT-3D has a transponder for the search and rescue system and also a data relay transponder that could collect information from the automatic weather platforms deployed in the landmass and in the sea around us.
Stefan Israel was in India earlier this month where he met with ISRO, traveled in the US, visiting customers and satellite builders from Intelsat, Boeing, DirecTV, EchoStar, and SS Loral, outlining midterm improvements for Ariane 5, which include adding up to 2 meters to the height of the fairing by 2015. Coming up on extinction of the upper stage, Jean-Claude, you'll hear the DDO call out. You can see the nozzle shutting down. This is the scheduled, you can see on the screen, the scheduled cutoff. The proper telemetry often has a lag of a second or two before it gets in here. But you have the confirmation now, no more power.
So after this engine shutdown, the attitude and control system called SCAR uses a hydrogen engine to control the roll during the propel phase. And the same system is used for the 3-axis stabilization control during the ballistic phase where we are now.
Things are still happening even though we're finished with the propulsion phase. We'll be back with satellite separation. But before that, the latest news from Arianespace. The journey began for O3b June 25th when a Soyuz placed in orbit the first 4 O3b satellites, which are in perfect health. The 3-ton cluster offers internet access to areas until now without any. It was the first of 12 O3b satellites that will be orbited by Arianespace in groups of 4.
End of August, the next Ariane 5 mission, Flight 215, will place into orbit Eutelsat 25B, SIL-1 for a newcomer in the satellite business, SILSat from Qatar, and GSAT-7, again for India and ISRO.
And the next Soyuz, Flight 6, will continue delivery of the O3b constellation with another 4 satellites. Launcher integration operations have been completed by our Russian partners, and the 4 satellites arrive in Kourou August 8th for their mission at the end of September.
A task force from ESA, Arianespace and Italian industry has compiled an analysis of flight parameters following the successful second flight of Vega last May. Their findings should lead to improvements in performance in the new light European launcher scheduled to fly twice next year.
I want to say that campaigns running in parallel, like you saw in the news there, are only possible thanks to the state-of-the-art industrial organization found here at Europe's spaceport. Coming up on separation of our first passenger, Alphasat, due in about 20 seconds, 27 minutes and 38 seconds to be exact. You'll hear the DDO call out that information.
And let's add that Arianespace launched the first Inmarsat in December 1981. It was launch number 4, which came just after Ariane launched with the first Indian satellite previous June on launch number 3. Both were delivered by Ariane 1, and the Inmarsat weighed just under 1 ton, and Apple capsule was 670 kg.
1 ton and not even 1 ton in those days. You see how the satellites have evolved in their weight. We're waiting for confirmation of separation of Alphasat, moment of
Séparation du satellite
concentration, focus for everybody. There's the first good news. Successful delivery of our upper passenger. You see what happens? She's pushed away from the mothership there, a series of springs. You notice in the hall here the people very politely holding their applause for the next passenger. That's become something of a tradition here at the space base. Now that Alphasat is up, its first operations, Claude.
So acquisition will be by the Beijing station, then 20 minutes after separation and 25 minutes after that will be a formal spacecraft health check. Partial solar redeployment is next. But now, let's talk about this.
Yeah, we had a look at the launch center before liftoff. Now our cameras are going up to another center of action called the CVI, the Immediate Visual Control Center. What goes on here?
So this facility is located south of the space base and high on a hill with excellent visibility. It has all the means for receiving, processing and storing the telemetry data that is being transmitted by Ariane. And right now a number of people are following and analyzing the key flight data. They are working in real time, reporting the flight status to the team back here in Jupiter building. So remember, Jupiter Mission Control Center is a nerve center in its contact with the facilities needed for launching and following Ariane.
Before we have separation of the Silda, that's the black bell-shaped structure you see there, under which is INSAT. You want to say a word about ISRO?
Yes, because ISRO main goal has been to develop space technology and its application to national tasks since 1969, when it was set up. So ISRO has established space systems like INSAT for telecommunication, TV broadcasting and weather services like tonight.
We're waiting for separation of the Silda. There's the scheduled.
Séparation du Silda.
And there's the confirmation by the DDO, pushed away from the mothership again with the same series of springs, revealing INSAT-3D. Now we're in what we call the ballistics phase, no more power. Give us an explanation of what's going on.
So the ballistic phase following the upper stage shutdown is for several things. Payload pointing in the direction required by Alphasat, preparing Alphasat separation with a longitudinal spin of 2.5% per second, and pointing and separation of the Silda.
Now all these have already happened.
Yes. Now we are witnessing the pointing and 3-axis stabilized phase required by INSAT-3D.
Our last film.
So Arianespace and INSAT go back on a long way. In our finite film, you get a look on that long and fruitful relationship.
INSAT-3D spacecraft is having imager instrument and sounder instrument. It provides environmental system of observation so that storm, hurricane and other activities can be monitored in real time to save property as well as human life. Also, it monitors Earth's atmosphere, Earth's surface temperature and other properties. At the same time, ocean temperature and all parameters are monitored to help people in India. That satellite reached in Kourou on 11th June 2013. Then following activities were carried out. Number one, IST of all subsystems. Number two, propellant loading. Number three, assembly with the launcher. Then in carrying out all these activities, our cooperation from CSG team, Ariane team was excellent. They have cooperated excellently and all they have contributed towards completing the activities in time and as per the schedule. ISRO has been carrying out the 16th launch of the satellite from French Guiana, Kourou. We have been launching these satellites since long time, and each time we get better performance of the launcher. So each time we expect in future also this relationship will improve, like earlier we have seen.
We are waiting for separation of our final passenger, INSAT-3D. You can see on the right of the screen, due in less than 1 minute, 32:41 exactly. Again, one of these moments of high concentration for everybody.
Tonight represents months, sometimes years of work for some of the people here and around the world. The mood in Jupiter is, I would say, very focused. Yeah. Although most of the people working here have gone through this before, it is still a moment of very high concentration.
Now you've gone through this before. What's the mood like usually down there among the technical people and the customers 1 minute before separation?
So, you know, as soon as the first satellite has been separated, its team is already at work on the first operation. INSAT-3D teams are still very concentrated and will be anti-separation has been confirmed.
And that separation should be confirmed in just a few short seconds. You'll be hearing the DDO call out, waiting for the news there on the INSAT side.
Séparation du satellite INSAT-3D.
Well done.
And right on target, this was done at 2,152 kilometers altitude.
So from the tense minutes just moments ago, you see the change here in Jupiter, very buoyant. Pats on the back, all across the Space Center and all at the points and posts where people are working or following the launcher and the satellite. Work just beginning, or soon will be, at the different ground stations for INSAT and at other sites around the world where the satellite's first maneuvers are being monitored.
And this is a code around the world at all the outposts and offices where people involved in Alphasat in Toulouse and INSAT in Bangalore and Hassan are following the happy outcome of events.
We're going to go to some launch replays in a moment. Before we do, we want to get the early orbit phase, as we did with Alphasat. Take a look at the first maneuvers. The Hassan Mission Control Center actually picks up the signal before it's separated.
And this is due to the geographical position of Hassan in southwestern India, very close to where Ariane is now. She has flown over Africa, and now it's above the Indian Ocean. So this station is near enough to see the launcher, and with it, of course, the satellite telemetry data. This is unlike Alphasat, whose first station to receive signal was in Beijing, too far to see Ariane.
Right. And the rest of the early orbit phase operations?
So in the next 4 hours, days, let's say, we will have 3 apogee motor firings. Then INSAT final positioning will take another 5 days.
Well, we're waiting now for the traditional post-launch speeches. We'll be hearing from Stéphane Israël, Chairman and CEO of Arianespace. We'll be hearing from Jean-Jacques Dordain, who you saw on the screen, the Director General of ESA.
We will also follow David Willett, the UK Minister of State for Universities and Sciences, then Rupert Pearce, CEO of Inmarsat, and Dr. Radhakrishnan of ISRO, again by video, and finally from Joël Barr, Director General Delegate of CNES.
So these gentlemen, those who are present today, will be shortly making their ways out from the fishbowl, what they call the fishbowl, the technical, that's the wall of glass in red you see behind them, there where the operational technical people and the customers, ESA, CNES, and Arianespace representatives are. They'll be making their way out from there, out here, to the other side of Jupiter Mission Control, where the VIPs and invited guests are. The podium and its microphones are ready for them now. Mr. Dordain, I can see with David Willits and Rupert Pierce chatting, waiting for Stefan Israel to make his way. He's on the other side. Probably he's shaking hands, maybe even exchanging cigars with some of his colleagues. That's a tradition here, another tradition here. While we're waiting for the speeches, we're going to go, as I mentioned, to a series of launch replays. And you can watch once again those exciting pictures as Ariane left the pad here in French Guiana, what was it, just over half an hour ago. We're getting those pictures ready for you. So what you're seeing is the aftermath of another successful launch as Ariane 5 has once again delivered as two new satellites, a weather satellite and a telecom satellite, begin their life. And you can see the smiles all around with the Arianespace people.
Future time.
And the customers. We're waiting for Stefan Israel to make his way up to the podium. I think everything is ready. The cameras are set up. Here's the replays. Stefan Israel, Chairman and CEO of Arianespace, has made his way out to this side of Jupiter, and he's approaching the podium now. Mr. Israel, you have the floor.
So, dear Right Honorable David Willett, ladies and gentlemen, distinguished customers and guests, I am pleased to confirm that today's Arianespace launch mission is a full success, deploying Alphasat and INSAT-3D into the desired geostationary transfer orbits. Congratulations to Arianespace team for this perfect launch. This was the 70th Ariane 5 manufactured by Europe's launcher industry with Astrium as a prime and operated by Arianespace. It also was the 56th consecutive success for Ariane 5, representing another significant milestone in our fruitful and long-standing public-private partnership between institutions and industry. A cooperation established to provide Europe with guaranteed access to space and to provide our customers with the most reliable launch solution. Once again, Ariane 5 unmatched reliability and availability has set the highest standards in the satellite launch business. I am proud these standards have today benefited two key customers, Inmarsat and ISRO, who both chose Arianespace the same year, it was in 1981, and whose two satellites programs share much in common with us. Alphasat, just like Ariane 5, is a vivid example of the best technology Europe offers through the implementation of efficient public-private partnerships. Indeed, Alphasat, the largest telecommunications spacecraft ever built in Europe, is a result of a fruitful cooperation between Inmarsat and the European Space Agency. It uses Alphabus, a new platform developed jointly by Astrium and Thales Alenia Space, with the support of ESA and CNES, to bring a European answer to the growing demand for more powerful telecommunication satellites. I thus want to thank Inmarsat, represented tonight by Mr. Rupert Pierce, its Chief Executive Officer, to have entrusted Arianespace for the launch of this pioneering mission, the 8th time we have launched a payload for Inmarsat since 1981. It is a real pleasure for Arianespace to welcome Inmarsat back in French Guiana and to have Rupert with us tonight. I also want to thank the European Space Agency through its General Director, Jean-Jacques Dordain, and Magali Vessière, Director for Telecommunications, for ESA's continuous involvement and support in this challenging program at both satellite and launch vehicle levels. In addition, let me take this opportunity to tell to British Minister for Universities and Science, the Right Honourable David Willets, that his presence here tonight in CSG is a great honor for all of us. On behalf of Arianespace, I want to express our gratitude to the United Kingdom for its significant involvement in the Alphasat program, and more globally, its increasing contribution to European space programs. As I said earlier, we have a lot in common with both satellite programs involved with today's missions. This is true as well, for sure, for INSAT-3D. INSAT-3D is the 16th satellite launched by Arianespace for the Indian Space Research Organization, ISRO. This long-standing cooperation dates back to the very beginning of Ariane adventure with Apple's launch in June 1981 on the third Ariane first flight. It represents more than 32 years of uninterrupted relationship between Ariane and ISRO. There are not so many couples who can boast about such longevity. Today's mission will be followed by another one for ISRO. Indeed, another Indian satellite is being prepared here at the spaceport right now, GSAT-7, scheduled to fly at the end of August, again on an Ariane 5 launcher. So let me once again express my personal gratitude to Dr. Radhakrishnan, ISRO chairman, for continuing this successful cooperation, and to Dr. Shiva Kumar, Director of the ISRO Satellite Center, ISAC, for his presence here today. These excellent relations between Arianespace and ISRO take place in the context of an ambitious cooperation between France, Europe, and India for space. This is why I want to congratulate warmly ISRO for the success of its PSLV launcher, the last one having been dedicated to the Indian navigation program. I know that ISRO is now preparing a launch with its GSLV, and I wish you the best for this new mission. Coming back to the two satellites we have just launched, I would like to add that Arianespace pride is all the greater when contributing to satellite missions whose purpose is to improve everyday people's life on Earth. Tonight's payloads are emblematic from this standpoint. Alphasat will indeed increase Inmarsat's capabilities to deliver mobile data and voice services via satellite, with enhanced flexibility to better meet the peak demands observed in disaster management on humanitarian crises. INSAT-3D is a meteorological satellite that also includes two payloads dedicated to cyclone warning and to search and rescue in order to improve the efficiency in predicting and handling emergency weather issues in India. So tonight, we passed our exam with Ariane 5, but as some of you may know, July is also a very special moment for young French students around 18 years old seeking graduation from high school before going to university. I shall now congratulate Caroline Hourier, who came first in this exam with an average of 21 out of 20, which is quite exceptional. So she came first in this exam in France, and whom Arianespace invited to attend this launch. Caroline has expressed a desire to work in the space sector after the completion of her studies. Space, which is the best sector, needs the best students. This is why Caroline is with us tonight. She is a symbol of excellence, the same excellence that all Ariane teams, wherever they are, in Europe or in French Guiana, try and reach when building and operating Ariane 5 for the benefit of our customers, to whom now I leave the floor. Thank you very much.
Well, thank you very much indeed. It's a great privilege for me to be here with you this evening on behalf of the British government. I'd like to congratulate all the different contributors to this triumphant success. I congratulate ESA and CNES and Arianespace for an exceptional launch. I also congratulate the teams from EADS Astrium, including in Portsmouth, very close to my own constituency, and from Thales as well, for the work they've done on this exceptional project. And of course, Inmarsat, who are based in London, who have spearheaded this program with such great skill. And I'd also like to extend my congratulations to our Indian friends. I have happy memories of visiting ISRO in Bangalore, and I congratulate the Indian team on their satellite as well. Now, this is the first satellite launch that I have ever experienced, and it was good to see it handled with the Cartesian precision I would expect from French engineers and scientists, and I congratulate CNES and ESA on that. But for me, the excitement was also heading out through those red doors and the elemental force that we saw and then, after a little while, heard. And I think that reminds us all of the sheer excitement of what space can do. It's why we in the British government are absolutely committed to working with our partners in ESA on space. I'm pleased that the UK Space Agency was able to play a significant role in this program. And after the ESA ministerial last year, we will be playing a significant role in many other European programs in the future. And I very much look forward to continuing successes and successful launches from this excellent facility. Thank you very much indeed.
Thank you, David, for those kind words. To everyone involved with this tremendous event, it was incredibly spectacular. I have to accept, as we were introduced by ESA, that as a loyal British subject and as a loyal English company headquartered in London, we have to accept that this week we're probably not the most important delivery of a baby. But nonetheless, we are absolutely thrilled that we've now successfully delivered Alphasat into space. Alphasat, Europe's largest and most sophisticated telecommunications satellite ever built. Tremendous testament to the innovation and creativity and talent of so many in European agencies, governments, and of course across the spectrum of the European space industry. So it's a very exciting future. Alphasat now sails across over Africa to deliver an incredible array of innovative services and solutions for a part of the world that is relatively unconnected and has great need of those solutions, and we, Inmarsat, will be very proud to deliver those for the next 25 years. Inmarsat has been operating satellites for over 30 years, but I can safely say that the launch never loses its power to amaze, and like you, David, standing outside and hearing that sonic boom was an impressive moment indeed. Many congratulations to the Arianespace team, and thank you for managing and hosting another successful launch. I'm sorry it's been a while since we've been back, but we won't be a stranger in future, I can assure you. I'd also like to thank all the engineers and other operational and support staff at Inmarsat. Without their hard work and dedication, Alphasat would have remained just a concept. Thanks are also due to our partners at ESA. This has been very much a joint endeavor and an outstanding example of what Europe's space industry can achieve when we work together. And I cannot let the evening end without a further thank you to Astrium and Thales for building the largest commercial communications satellite ever constructed in Europe and for delivering an unbelievable digital transparent processor to ensure that this satellite will be among the most efficient, agile, and effective on the planet, or off the planet indeed. And finally, to the UK Space Agency, the European Investment Bank, and 3 UK development agencies who have played themselves a crucial role in the development of Alphasat. But just to finish, the launch has just started the journey for Inmarsat. I can announce that my colleagues back in Europe have just successfully acquired the satellite and will be working throughout the night to achieve partial array deployment. And then on Friday night, they will begin the first of 4 burns to raise Alphasat into its final orbit, an operation which is scheduled to be completed by Wednesday morning. So, if all goes well, Alphasat will be configured and Earth pointing on the 4th of August. So, congratulations again to everyone involved. Thank you.
Mr. Minister, dear colleagues, dear friends, yes, I shall start myself again with a new baby. So it's not a royal baby, but much bigger, and with much more many fathers. That this is for sure. And I must say that the first news from the baby that I got from Rui are good. I think that the first news were coming from Beijing, I was told, and but okay, the baby looks okay. Obviously, even if he has still to cross a lot of steps before becoming the king of telecommunications. So I would like at this stage to thank Arianespace. Because for you the work is over, even if for the others the work is just starting. For you the work is over, and I would like to thank you again for this beautiful and successful launch of Ariane 5. As you know, I fully trust Arianespace, and when I say fully, I would say 200%, because it's 100%. Since we ask Arianespace to exploit the launchers developed by ESA, and 100% because we are using Arianespace every time we have an ESA mission, including when ESA as a partner, because we have succeeded to put ILAS on Ariane, to put Alphasat today on Ariane, and the next one, AG1 on Ariane. So I am not saying that this is totally natural, but this is just a fact. Meaning that ESA is very faithful to Arianespace, but grateful to Arianespace also. The reliability of Arianespace is based first on the reliability of the European launcher industry. I think that there could not be a reliable launcher without a reliable European launcher industry under the leadership of Astrium when it concerns Ariane 5, but also on the reliability of CNES and the ground industry, the ground facilities industry here in Kourou, because this is a fantastic launch base. So when you combine a reliable launcher and a reliable launch base, this is the result. So thank you all for this beautiful launch. It's always an event full of emotion, and I would say a relief when it is a success. It's a good start, but it's only the start. It's only a start because for satellite industry, this is the start of a concrete demonstration of their level of innovation and their level of competitiveness. This is why we have made Alphasat. For ESA, this is the start of an in-orbit qualification of a lot of new technologies which will be used at a later stage on operational missions. And for Inmarsat, this is the start of operations and exploitation of this new satellite, which is, and I quote Rupert, as he said this morning, Alphasat is the most powerful, the most flexible, and the most efficient satellite for mobile communications. Thank you for that quote, and I shall use it again. As I said this morning, Alphasat is a paradigm change for ESA, and based on Alphasat heritage, but also Alphasat lessons learned, because we can still improve. We are developing more and more partnerships in the telecommunication fields. So we are at the end of the development of AG1 with Hispasat, and AG1 is planned to be launched next year on board Ariane 5. And as you know, AG1 is under the leadership of Germany. Today we are speaking of France and UK, but next year we shall speak of the leadership of Germany in telecommunications. Then we shall have the data relay satellite with Astrium services, and which will be based on the laser terminal, which is mounted today on Alphasat. and which will introduce another paradigm change in the way we shall exploit Earth observation satellites and providing Earth observation data in quasi-real time. Then we shall have NEOSat, the new generation of platform for telecommunications, which will be based on an even better agreement between ESA, CNES, Thales, and Astrium than the one on Alphasat, meaning that we can still improve. We shall have Electra also as an improvement of the small GEO platform through electric propulsion in partnership with SOS, and again under the leadership of Germany. And then I hope, Mr. Minister, that we shall have Hercules, which will be the second applications using the platform Alphabus, which is the project under which we are working with our British colleagues. So as you can see, we should be here more and more often for this type of event in Kourou for all these missions which are still to come. So I would like to thank all those who trust in ESA for developing innovation and competitiveness. Yes, ESA is certainly a good place to invest in innovation and in competitiveness. And among the ones who trust ESA, I would like, obviously, to start by the member states. And today, as I said, it's mostly France and UK. Next year, it will be Germany, demonstrating that we have a lot of supporters at ESA. And speaking of UK, I would like to thank you, Mr. Minister, to be with us today. I know that your calendar is tight, but your presence is a demonstration that you are putting a lot of interest in what we are doing, and we really appreciate that. All my colleagues and myself, we value your presence, and obviously you are welcome anytime you want in Kourou. As I told you, you are at home, and you are at the right place also, demonstrating that Europe can be very high in the sky. But I would like also to thank the partners who are taking ESA as their partner, and especially industry, but also operator, and today Inmarsat. And yes, I think that ESA is a reliable partner, which delivers, thanks to maybe to the difficulty of taking decisions at ESA. As I said many times, it's difficult to start a program at ESA, but it's even more difficult to stop a program, meaning that it makes ESA the most reliable partner of the world. And so it's thanks to the member states, but it's also thanks to its people. The people of ESA, but the people who are working with ESA, meaning that the people of our partners. So thank you all. You have made my day, and let's continue together. Thank you.
On behalf of the entire ISRO, I compliment Arianespace for the successful launch of Ariane 5 VA214 and for successfully placing both INSAT-3D and Alphasat into geosynchronous transfer orbit. This is another milestone in the long-standing relationship between ISRO and Arianespace. I'm happy to inform that the master control facility at Hassan in India has already received signals from INSAT-3D. During the next 4 days, we have 3 critical orbital maneuvers to be commanded from master control facility. And we would be placing INSAT-3D into the geostationary orbit. And within a fortnight, INSAT-3D would be positioned in its designated orbital slot of 82 degrees east longitude. The switching on and testing of the payloads would then commence. And we are looking forward to an excellent operational performance of INSAT-3D for the next 7 years, making a difference for the weather forecasting and disaster warning systems for the country. I take this opportunity to thank the entire team from ISRO who worked tirelessly for realizing this satellite. And along with the India Meteorology Department, we would be making the best use of the capabilities of INSAT-3D for the country, for the people. Thank you.
On behalf of Indian Space Research Organization, on behalf of Chairman ISRO, and on behalf of all of us who are here, the project team and all of us who have come here for witnessing the launch, all of us would like to specifically thank Arianespace for the excellent launch that they have carried out today. It is wonderful. We're watching it going so good for us on dot. And as Chairman ISRO told, we've already acquired and then done the deployment also on the satellite. That means one of the major hurdles of operations is over. Now we are going ahead with the rest of the operations on a standard geostationary mission. It's wonderful that we have been part of Arianespace, as Chairman was telling that it's for the 16th time we have come here for this specific launch. And it went on so well for us. It was quite a good partnership that we have had. And we always look for next success in the next month itself as we go along for our GSAT-7 launch. Also done, all is well for ISRO, and also all is well for Arianespace. And we would like to congratulate our colleagues from Alphasat for having got a good mission to start off. I'm sure that they will certainly have a good mission for days to come. So good things have begun, and we hope that INSAT-3D will really fulfill our objectives of whatever that we have set for MET applications within the country, and hopefully it will certainly meet its entire mission life duration. So thanks again for everything, and we'll come back again probably next month. Thank you very much.
Mr. Minister, dear Indian colleagues, je vais parler français, si vous me permettez.
If you allow me, I will switch to French to say in a few words. The first thing, of course, is to congratulate all of the partners in the Alphasat and Alphabus program, and to say, as Jean-Claude Bonnet said and other speakers today, that cooperation works. This is the proof of the pudding between ESA, CNES, between Astrium and Alcatel. Oh, Alcatel, I did it again. It's Thales and Space. It's my second time today that I have a slip of the tongue. So this cooperation works and will continue to work in the future with other programs which we will be preparing with the various satellites. So thank you again to our colleagues from ISRO for putting their trust in Ariane for the 16th time, if I'm not mistaken. Thank you for ISRO for this cooperation that we have had continuously with CNES and over the years. Thank you to Ariane, and the whole community, the 70th launch of Ariane, 56 successful launches in a row. That's a good record. So we are strong believers in Ariane and its future, and we fully believe as we said earlier, with Jack and its prospects. And thank you to CSG. We've just had 3 launches in 2 months, 2 Ariane 5s and 1 Soyuz, 3 totally different missions. ATV, ISO-3D with Soyuz, and today with this Alphasat launch with Alphasat and INSAT-3D. So great performance from the CNERCs, Arianespace, and all the launch range teams, as some of them are present here. And thank you again to Guyana. I would like to commend the Prefect and the various members of Parliament present here, all our Guyanese guests who follow us at every launch and who help us in these feats that are not only technological, but it's all about people first, and Guyana is part and parcel of this adventure. So thank you to all, and I think we deserve to celebrate together. I'm not in charge, but I think that things have been planned. Stéphane will tell you more.
So yes, just a few words as a conclusion. So the Indian summer goes on for Arianespace and ISRO, because our next launch should be end August. Today's targeted day is the 29th. And we will have an ISRO passenger with GSAT-7. GSAT-7 is already here in CSG, and everything is okay. And the other passenger will be SL-1. Eutelsat 25B, so it will be a satellite cooperated by Eutelsat and SAILSat, which is a newcomer in our community. This comer is from Qatar, and we are very proud to have this launch in August. So thanks again to everybody, and now enjoy the evening. Thank you very much. Bye-bye.
With references to the royal baby, the speakers representing the main players in the mission, all offering congratulations to everyone involved before the VIPs and the invited guests here in Jupiter. We're going to say goodbye over some last shots of the replay, I believe. Before we do that, Claude, any last words?
Now, talking about babies, let's talk about twins born today for the space activities, Alphasat and INSAT-3D. So we follow this exciting countdown. Another one was to work with you here, George. Oh. Thank you so much. Thank you to our supported team, the conductor and Guyane Première. Et bon anniversaire, Marie-Aline. Happy birthday, Marie-Aline.
Happy birthday to Marie-Aline. Well, that'll do it from us, from Kourou, and from the Guyana Space Center Jupiter Mission Control, where the big news is, of course, that Ariane 5 has once again delivered 2 new satellites beginning life now. These are the replay shots. You can relive those exciting moments that we saw. Alphasat for Inmarsat and INSAT-3D for India. That makes 56 straight successful launches for Ariane 5. Next launch next month, as Stéphane Israel said, August 29th is the target date. We'll be here. We hope you will be too. Until then, Joshua Jample with my old friend Claude Berna saying thanks for being with us. We hope you enjoyed it. We certainly did. And we look forward to being with you next time. Good day, everybody.